These are our notes on area and sectors. Area of a circle, the formula for that is area equals pi r squared. Area of a sector of a circle, here's your formula for that. Area equals measure of arc over 360 times pi r squared. If we were to find the area of circle A, here's circle A here, we would take our formula that we just said, area equals pi r squared, and plug in our values. So we would have area equals pi, and we can see here on circle A that our radius is 15 inches. So we would put pi 15 squared. So our answer for that would be that area equals 225 pi. And that would be our area of circle A. The next thing we want to find is our area of sector BAC. So here's BAC right here. And to find the area of sector, remember, here's our formula. So we're just going to plug those in. So first of all, I'm going to say area equals, and we want to find the measure of our arc. So looking down here for BAC, the measure of our arc is 42. So we're just going to put 42 over 360. And then I'm going to multiply that times pi r squared. Oops. And I'm actually going to put our r value in, which is 15. So we're going to have pi 15 squared. And that, when you plug it in your calculator, remember we just did it above, is 225 pi. So when we take 42 times 225, that's going to give us 9,450 pi over our 360. And that equals 26.25 pi. So here I just rewrote this so we could see it better. And I also showed how we could solve this by just reducing the fractions down as we went along. So this is if you're just plugging in your calculator. This is if you're reducing the fractions down to solve for it. And we still come up with 26.25. To find the area of sector BAD, so in this case we're looking at area of sector BAD here. To find that, we can figure that we've got, so to do this, we first have to find what is our measure here. And I can see this is 190 and 42, so to do that, we could just take our 360 minus our 232, which is just these two added together, and that's going to leave us with 128. So we know that this is 128. So to find the area of sector BAD, we're just going to take 128 divided by our 360. So again, I'm just using this equation right up here. And then we're going to multiply that times pi. Our radius is still 15. So that's going to be 225 pi. And then when we plug that in, that gives us 28,800 over 360. And when we calculate, and oops, sorry, we'll leave our pi on there. And that leaves us with 80 pi. And if I were just to reduce this down like I did the last one, this would look like this. We would take 32 over 90 times 225 pi, and then that would equal 7,200 over 90, and I could just cross my zeros out, and we would still have pi here. That would equal 720 over 90, or over 9, sorry. And my overall answer would be still 80 pi. So that's what you give for your answer, 80 pi for that one. Here's a different example. We want to find the segment of a circle area, and this is a right triangle example. So the first thing I want to do is find the area of the sector. So I'm looking at this, and I know that we've got 90 degrees. So to plug it into my equation, we're going to take area equals, and we would take our 90 divided by 360, multiply that times pi r squared. I can see here that my radius is 10, so times 10 squared, and we know that that's going to equal 100 pi. So I'm just going to put that down there. And when we calculate that out, we would get 9,000 pi over 360, and that equals 25 pi. If I were to reduce it down instead, I'm just going to write it that way too. We could reduce this down to, we could reduce this down to 1/4 and multiply that times your 100 pi, and that would give us again 25 pi. So we get the same answer either way. All right, now we need to find the area of our triangle. So same as before, we're just going to take 1/2 base times height. And when you start plugging those in, we've got 1/2 times 10 times 10. So when we have 1/2 times 100, that's going to equal 50. And we can see here that we're dealing with inches. So 50 inches squared is what we get for that. That's our area of our triangle. And now, just like we did before, now we've got to subtract the two to figure it out. So I'm going to take my 25 pi minus 50, and that is going to give us 28.5. And that's going to be my segment of the circle area. On this last example, we're using a 30, 60, 90 triangle. So if we look at this one, we again want to find the area of the sector. So looking at this triangle, I can see that this angle is 120. So what I'm going to do here is just split my triangle right into two. And when we do that, it gives us our right angle here. And if we have our right angle there, then we know that since this one is 120, that's going to make this 60 and this 60, which means our 30-degree angles are down here. Okay, so that's how we're going to set that up. Our next step is we need to try to find, we can also solve for these other sides here. So I'm going to do that in just a minute. The first thing I'm going to do is solve for our area of a sector. So I'm just going to write that on here, and we can go ahead and solve. We know that our measure of our arc is 120. So I'm just going to put up here 120 divided by 360. And we're going to multiply that by pi r. And in this case, our radius is 18. So pi r squared. And that gives you 324 pi. And then when we calculate that out, we get So 38,880 divided by 360. And that gives you 108 pi. If I were to reduce this down, we could take 120 divided by 360. Again, we can cross off these zeros, and that equals 1/3 times 324 pi. And that, when you plug it in, will also give you 108 pi. All right, now we're going to find the dimensions of the triangle. So we already know that we have split apart here. I kind of showed you we could split it apart to get our 30, 60, 90. So these are both 60, these are 30. We know that these angles are 90. So I'm going to go ahead and set up my 30, 60, 90 table. Because as of right now, the only side that I know is my side across from the 90-degree angle, my hypotenuse. So we're just going to go ahead and set up our table. And the side that we know is right here, the side across from our 90-degree angle. So I'm just going to write that in, would be 18. And when we solve for that, we know that if 2x equals 18, we know that x equals 9. So I can plug my 9 in here, and that would make this 9 square roots of 3. So our long side, I can write that down here, our short side is going to equal 9, which would be, let me change my color here. So this side is going to be 9. And then our long side here is going to be 9 square roots of 3. And I'm just going to write it like this. Long side would equal 9 square roots of 3, which also equals 15.6. So however you want to write it, but in the decimal form it'd be that. So up here I'm just going to put 9 square roots of 3 would be this side here, and also that side. So we just know the dimensions of our triangle. Now we want to find the area of our triangle. So we know that's 1/2 times base times height. So in this case, we're going to have 1/2 times. Now in this case, we have 2 because we split it in half. So if each of our long sides for our base is 9 square roots of 3, we have to multiply that by 2, which would give you 18 square roots of 3, or 31.18. So I'm just going to write that in there, 2 times 9 square roots of 3, or, so I'm going to put that like this, times your height is 9. So that would equal 140.3 inches squared. And under here, I'm just going to rewrite that with our decimal form. So we'd say 1/2 times 31.2 times 9. And that's still going to give us our same answer of 140.3 inches squared. So that's what our area of our triangle would be. And now we need to just subtract the 2. So you'd have 108 pi minus 140.3, and that will give you 199. And that is our final answer.